Hello and welcome back to another episode of Math with Son. Today we're going to be doing AP Physics 1 and we're starting impulse and momentum. So throughout this entire video we're going to try and distinguish what is impulse and what is momentum and how are they different. All right, so for starters, momentum is a vector quantity. It is denoted by a lowercase p and it is equivalent to mass times velocity. So that's the formula for it. And a lot of times, a lot of people get confused about what is momentum. The easiest way for me to think about what momentum is it is thought of as how difficult an object is to stop. That is in motion. Okay, so if an object is in motion, how hard would it be to stop said object? All right. So we had an example here. We got a llama that has a mass of 90 kilograms and it gallops at 2 meters per second. And another llama, or an alpaca, is 60 kilograms and is running at 3 meters per second. We are going to compare the inertia and the momentum of each thing. Well, the llama that is moving at 2 meters per second was 90 kilograms, and therefore it would have a momentum of 180 kilograms per meters per second. Meters per second, excuse me. And there is no unit for momentum, so it's this ugly kilograms meters per second. But the alpaca, even though it was smaller because it was running faster, would also have the exact same momentum, indicating a few things. If an object is bigger, it does not have to be moving as quickly to have the same momentum as something that is smaller. So the smaller an object is, the quicker it would have to be moving for it to stop. It would be harder to stop the faster you move. And also, conversely, the bigger it is, the harder it would be to stop. All right? Now, this question asks for two things. It asks for momentum. The momentum is the same. But we kind of addressed that the bigger the object is, the harder it is to stop. And the quicker it is moving, the bigger the velocity, the harder it would be to stop as well. Inertia is how likely something, how much it doesn't like to be moved in general. Okay? Momentum is different than inertia. Inertia is how hard is it to change its movement in general. That would be stopping as well as starting. And inertia is only affected specifically by how much the object weighs. So the llama that has more mass will have more inertia because making it have more mass would make it harder to change its acceleration. You would have to apply more force to something that is larger and has more mass to change its acceleration. Therefore, more mass, more inertia. All right? So, back to the actual impulse versus a momentum question. We're getting closer to impulse. And impulse is how much time or how quickly the momentum is changing. So, impulse is related to how quickly and how much time it takes for momentum to change. So we got some kinematic formulas here that I'm going to go over real quick. We have a regular velocity final is equal to velocity initial plus a times t. All right? And impulse is the change in momentum. So if you did vf minus vi, if you just subtracted the vi over, you would have at. And if you wanted to multiply everything by m, you could. Everything has a mass. So the mass times final velocity minus the mass times initial velocity would equal the mass times the acceleration times time. Well, what is mass times acceleration? That would be force. And if you divided by time, you could, this didn't, sorry, I've seen other formulas that do. You could think of mass times velocity as momentum and mass times velocity as momentum. And if you took your final momentum and your initial momentum, you would get the change in momentum. So the change in momentum, or the impulse, the change in momentum, your impulse, is equal to force times time, thus giving us that formula and the important parts for impulse, for right now at least. All right, so impulse by definition is the change in momentum and can be related to force applied over time. And momentum, impulse, momentum theory, they have a symbol, I've seen it called J as well as I, is equal to the change in momentum. And the change in momentum we just figured out is force times time. All right? Let's see, what else do we want to talk about in that? We're just going to talk about a little tiny bit here. and that'll springboard us into the next video. Going through these formulas real quick. What impulse is imparted to the mass? Well, that would be J is equal to force times time. That would be the formula for it. What is the change in momentum of the mass? Since the impulse is equal to the change in momentum, that means that the impulse is equal to the change in momentum is equal to force times time. And it even says here, if we wanted to figure out the change in speed of the mass, you could do that too, which is going to get towards collisions. That's what this is all springboarding us into. In Physics 1, the mass of the system should pretty much always be constant, because that would make things very difficult if it wasn't. Therefore, force times time will equal the mass times the change in velocity. All right? So, with that in mind, if you know that force times time is equal to mass times change in velocity, if you divide by m, you can figure out that the change in velocity, or the impulse, is equal to force times time divided by mass, which is still the same formulas we were dealing with on the other side. And you could continue that if you wanted to. You could think of force as mass times acceleration times time divided by m, and then they would cancel out, which makes sense because change velocity would be the acceleration times the time. All of this just fits together in different ways in manipulating a formulas. Before I ramble on too much further, the main reason we are doing this, the main reason that this is important, is that momentum and impulse relate to collisions. Up till now in physics, you were dealing with what happened before the collision, what happened after the collision, but never what was happening during the collision. So I impart you with this question as we leave. Why do airbags even exist? Okay? In terms of the collision, you went from going at 60 miles an hour supposedly, or in this case 15 meters per second, and then abruptly when you get into a car crash would stop. Okay, so no matter what, if you think about it, you were going from 60 to 0 miles per hour or kilometers per hour, whatever unit you would like. Why does the airbag need to be there? Why is that important? Because you went from 60 to 0. Your initial was 60, your final is 0. In both cases, airbag or not, you started with 60, you ended with 0. So what is the purpose of the airbag? And the answer to that is it slows down the collision. It changes, instead of going from 60 to 0 in the course of like a blink of an eye, maybe it slows it down to a half a second. And if you slow down that increment of time, then that collision actually imparts less force, okay? So, gonna get into that for the future videos, but that's why it's important, and I look forward to seeing you then. Bye now, everybody. See ya.